Okay, so now what we're going to do is start talking about Chapter 1. Chapter 1 is going through basically the economic way of thinking. It's just basically an introductory chapter. So basically we can define economics as the use of limited resources to satisfy unlimited wants. Limited resources are what we mean by scarce resources, but by scarcity we mean two things. We mean, first of all, that there's limited resources so that there's finite amounts of output, and then we assume that there's unlimited wants. So what that means is not everybody can get what they want, or if we're going to give more of a good to one person, we have to give less of another. That creates trade-offs. So economics is basically the study of these trade-offs. The economic problem comes about basically because of scarcity. So notice we've already made one assumption. We've assumed that wants are unlimited and then we have scarce resources. We're also going to assume that people act rationally, and by acting rationally we mean that they compare the marginal cost or the incremental cost of an action to the marginal benefit of doing that action. If the marginal benefit is higher than the marginal cost, then you're going to undertake that action. If it's the other way around, if the marginal cost is higher than the marginal benefit, then you're not going to do that action. Okay? And we're going to define what we mean by marginal cost in a minute. Okay? So we're going to focus on another definition of economics, which is that economics is the study of the use of scarce resources, there's scarcity again, the use of scarce resources to produce and distribute output. So we're going to be focusing on three questions, and the first question is what to produce. We can use our resources to produce many different goods. The next question is how to produce it. We want to use the smallest amount of resources to get the biggest amount of output. That's called cost minimization. And the last question is who gets what, or a distribution issue. And the way our system answers these questions is by using something called the price system or the market system. So what happens is, what defines the incentives for people when answering these questions is relative prices. Those give the incentives. So, for example, changes in prices give the incentives for changes in behavior. So, for example, suppose we're producing a lot of pens and bottles of water, and we as a society want more pens produced and fewer bottles of water. We want suppliers to put more resources into producing pens and less into bottles of water. Well, what do? Well, we buy more pens, right? As we buy more pens, the price of pens is going to go up. It's more profitable to make more pens, so producers are going to take more resources and put them into producing pens. On the other hand, we don't want bottles of water, so what's going to happen is we're going to stop buying bottles of water. Inventory is going to build up. Producers of bottles of water are going to use fewer resources to produce fewer bottles of water. And the price of bottled water is going to go down. It's less profitable to make bottled water. So producers of bottled water are going to go in the market and get less resources to make bottles of water. So changes in prices give the incentives for changes in behavior. And I just said that it's relative prices because the price of a good itself doesn't matter. It's the price of that good relative to the price of other goods. Okay? So for example, if I tell you that a cup of coffee at Starbucks is $50 and I ask if that's expensive, most of you would say yes. And the reason is because you know the cost of everything else, and you know, let's say, the donut that you would get along with the cup of coffee is $1. So that if you buy a $50 cup of coffee, you're giving up 50 donuts. That's a lot. But if I tell you that the donut that goes along with the cup of coffee is $100, now it's not so expensive to have $50 for coffee, right? That is, the relative prices are what matter, because what people really care about is giving up goods for goods. Okay? So we'll see that later. Mostly what we're going to be doing is talking about how the price system works. Microeconomics is looking at individual decision makers. So in this class, what we're going to be doing is looking at how individuals decide how much of each output they're going to buy. We're going to look at the individual firm and how an individual firm decides how much output and what price to charge. We'll look at individual firms when there's many firms, so there's lots of competition. We'll look at an individual firm when there's only one firm, that's a monopoly. We'll look at individual firms when there are what we call few firms. So there's some competition, but the firms are relatively large. Then we're going to look at how firms act in different competitive situations. Okay? So now we'll talk about how we're going to talk about economic issues. Okay? So what we're going to do is use the scientific method. And what that means is we're going to be building models of situations and then applying those models to the real world. Okay? A model is a representation of a theory. A theory is an idea of how the world works, and a model is a representation. So to build a model, the first thing you do is you come up with a question. There's some question you want to answer. And you look at the most important variables to that question. And what the most important variables are depends upon what the question is. So if you're an engineer and you want to know what happens to people in a crash, you can go down and put crash dummies in a car. And what you're going to care about is how fast the car is going. You're going to care about how much the dummies weigh, maybe how tall the dummies are, and where the dummies are in the car. But you're not going to care if the dummies have hair, and you're not going to care about if the dummies are colored, if some are blue or red or something like that. On the other hand, if the question you're asking is what happens to your hairstyle when you leave the window open in the car, then you care again about how fast the car is going. You care about how tall the dummies are, and you care about where the dummies are in the car. Now you care about the dummies of hair and what the hairdo looks like, but you don't care what color the dummy is still. Okay? So that's called doing abstraction, is trying to figure out what the most important variables are in this particular situation. Okay? Then you make some assumptions, like we made an assumption that people are rational. You sometimes make assumptions about the value of variables that you don't think are very important to the question, so you just set a particular value for them, or you make some other assumptions. Those assumptions don't have to be perfectly realistic to the real world, although most of the time the assumptions that we use are pretty realistic. So then what you do is you work through the model and you get a prediction of the model. One prediction, for example, is if people pay a lower price for a good, everything else being equal, that they're going to buy more of it. That's a prediction from a particular model of how people make choices. Then what you do is compare the prediction of the model to data. You actually go and test. If the data back up the prediction of the model, or the prediction of the model seems to do what data do in the real world, that gives evidence for your model of the way the world works, and you're going to accept that model or that theory until something better comes along. If it doesn't match, then you go back and try to figure out where you went wrong. For example, you might have gone wrong in including a variable you shouldn't have included, or maybe you didn't include a variable that you should have included. So then you try to go back over the model, make it better, and then compare it to the data again and see if it's any better. Okay. That's called doing the scientific method, and that's kind of the idea of what we're going to be doing in this class. We're going to be building models of how economic entities behave in certain situations, and then we're going to be comparing it to what happens in the real world to explain what happens in the real world. That's kind of the economic process. Okay? So now that we know what we're going to be doing in this class, let's go ahead and start doing it. The first thing to do is to define an opportunity cost. The opportunity cost of an economic action is the value of the next best alternative given up. So, for example, if the action what we're going to do is producing 1 unit of pen, it could be that the next best alternative was producing a certain amount of bottles of water. Okay? An opportunity cost is made up of explicit cost. Those are the expenses, that is, you actually pay money out of producing, of doing the particular action, plus the implicit cost, which are the cost, hypothetical cost, things you would have gotten if you had done the next best alternative use of the resources, but you didn't. So let's do an example of an opportunity cost of an action. Let's say the action is taking this class. Okay, so what are some of the opportunity cost of doing that action? Well, first of all, you have to pay for parking, you had to pay for the units, you had to pay for the book, etc. Those are things you actually paid money for. Those are expenses. Those are some of the explicit cost of actually taking the class. What are some of the implicit class costs? Well, the main one would be an intangible resource that you use up, and that's time, right? So you're using your time to take this class rather than do the next best alternative use of your time. Now, the next best alternative use of your time on, let's say, Saturday morning or Sunday morning might actually be sleeping, but I can't put a value on that. It's priceless, right? Okay, so what we would do is assume that the next best use of your time would be working in the marketplace, and we can value your time at how much you would have made if instead you were working for wages. So the entire opportunity cost of being in this class is what you actually paid for it, plus what you would have earned if you used the time instead in your next best use, which would be working. Okay? All actions have opportunity costs. It's possible that their implicit cost could be zero, but most of the time there's going to be implicit costs as well. That's true for a firm as well. Firms have implicit cost of production. So when we as economists talk about the cost of production, we mean the opportunity cost of production. That is, we're including the explicit cost and the implicit cost. In fact, we define the profits that firms maximize as economic profits. And economic profits are the total revenue minus the explicit cost, which is what we call accounting profits, and that whole amount minus the implicit cost. Okay. So what are some of the explicit costs of producing for a firm? Right? Well, they might have to pay labor, they might have to have the electricity on, you might have to pay rent for the factory, etc. Things like that. Again, things you actually paid money for. What are some of the implicit costs for a firm? Okay, well, maybe it's a small firm and the owner works there. So the owner's time would be an implicit cost. That is, we would value it at what else the owner could be doing with his time that is working somewhere else. Another implicit cost might be if the owner owns the machines that he's using, because instead of using the machines in the firm that he's working on, he could rent those machines to somebody else. So the rental rate that you're giving up by using the machines would be part of the implicit cost. Okay? Suppose the owner uses a room in his house as an office. If he uses a room in his house as an office, he's giving up what he could have earned by renting that room to somebody else. So the rental rate of the room would be another implicit cost. So when we say that firms are maximizing profits, what we mean is firms are maximizing economic profits, which is the total revenue minus the total opportunity costs. So opportunity costs are going to become important, okay? So the next thing we can do is look at how we look at an opportunity cost when we have different decisions. So let's say the decision for the consumer is buying something and the income is $30 and we have two goods that we can buy. The first one is whips and the second one is chains. Use this to make sure people wake up. Okay, so the price of a whip is $2 and the price of a chain is $1 and the budget line is given in the slide. Okay, the budget line shows us all the combinations of the two goods that the person can buy. So if the person uses all the money to buy chains, they can buy 30 chains. If they use all the money to buy whips, they could buy 15 whips. Or they could buy 5 whips and 20 chains that's marked, or you can buy 10 whips and 10 chains, etc. You can buy any combination of the two goods that lies on that line. Anything in the interior of the line is attainable or affordable but inefficient, because you could get the same number of whips and more chains. For example, if you were going to buy 10 whips and 6 chains, that would be inefficient because you can afford 10 chains, not just 6, and why would you stop? Okay, you're going to use up all the resources that you have. So you're going to spend all your money in buying both goods. In this case, the opportunity cost of buying one whip is 2 chains, because a whip costs $2. So if you buy a whip, you pay $2, and given each chain costs $1, $2 worth of chain is 2. So we would say that the opportunity cost of buying one whip is not buying 2 chains. Okay? Similarly, the opportunity cost of buying one chain would be half a whip, because if you buy a chain, you use up $1, and $1's worth of whip is one whip. It is 1/2 of a whip. Sorry. So that's how you use the budget line to look at opportunity cost. Okay. Then we can look at how the budget line changes when we change certain things ceteris paribus. Now, ceteris paribus is a phrase that means all things being equal, so it means we change only one thing. So suppose instead of having $30, I gave you $40 and the prices of the goods are still the same. Then your budget line would shift to the right. Now you'd be able to afford 40 chains and 20 whips. So you'd have a shift to the right of the budget line, but the slope of the budget line would stay the same. So the opportunity cost of buying a whip would still be 2 chains, and the opportunity cost of buying a chain would still be 1/2 a whip. The opportunity costs of the goods are given by the slope. Let's see what happens when we change the price of one of the goods. Okay, when we change the price of one of the goods, now we have a rotation of the budget line. So let's say now, ceteris paribus, we go back to the same initial budget line, and now the price of a whip, ceteris paribus, goes to $1. So you still have $30 and the price of a chain is still $1. Now the budget line rotates, because now you can still afford 30 chains, but now you can afford 30 whips. So the budget line becomes flatter. So 2 things happen. You can afford basically more whips and more chains than you had before, but it's also true that the opportunity cost of a whip falls to 1 chain, and the opportunity cost of buying a chain rises to 1 whip. So when you change the slope of the budget line, you change the opportunity cost. Okay, now let's look at a production possibility frontier. A production possibility frontier gives you all the combinations of two goods that you can produce given the technology and given the amount of the inputs that you have. So now let's assume that we have 30 pounds of leather. There's no input specialization. No input specialization means that every unit of leather is the same as every other unit of leather. It means every unit of the input is the same as every other unit of the input. So let's say it takes 2 pounds of leather to make one whip, and it takes 1 pound of leather to make one chain. Okay. The production possibility frontier we would get would again be the straight line from 30 to 15, because if we put all our leather into making chains, we can make 30. If we put all our leather into making whips, we can make 15. Or we can use all 30 pounds of leather to make any combination of whips and chains on the line. Again, anything in the interior is dominated, so you wouldn't be down there, and anything to the right of the production possibility frontier is unattainable given the resources that you have right now. Again, the opportunity cost of producing one whip now would be 2 chains, because if you produce one whip, you use up 2 pounds of leather that would have made 2 chains. And the opportunity cost of producing one chain is again half a whip that would have been produced. Okay. We can look at how the production possibility frontier changes if I change something ceteris paribus. So again, leave the technology the same, and you get 40 pounds of leather now. Again, the production possibility frontier would shift in a parallel shift, that is, the slope is the same, to the right. The slope of the production possibility frontier stays the same. So the opportunity cost of production, the opportunity cost of producing a whip, and the opportunity cost of producing a chain stay the same. Okay. If we look at changing the technology, again, we have a rotation of the production possibility frontier. So we go back to having 30 pounds of leather and the same technology. And now, let's say ceteris paribus, it only takes 1 pound of leather to make one whip and 1 pound of leather to make one chain. Now again, the production possibility frontier is going to rotate. It becomes flatter, because now we can make a maximum of 30 whips and 30 chains instead of 30 and 15. So now the slope of the production possibility frontier has become flatter, so the opportunity cost of producing a whip has fallen to 1 chain, and the opportunity cost of producing a chain has risen to 1 whip. So again, we have a rotation. So if you change how many pounds of leather it takes to make one whip, you're going to rotate the production possibility frontier through the point of 30 chains. And if you change how many units of leather it takes to make one whip, you're going to rotate the production possibility frontier through the point of 15 whips. Okay. The easier it is to make a chain, the steeper the production possibility frontier is, the more pounds of leather it takes to make a chain, the flatter the production possibility frontier is. Okay. Now, let's look at what happens when we have input specialization. Okay. Input specialization means every unit of input is not the same as every other unit. There's some inputs that are better at producing whips. There's some inputs that are better at producing chains. So we have now 30 pounds of leather and 20 units of labor, and I'm telling you that 60% of these resources are better at chains and 40% are better at whips. Okay, what that means is some of the leather is very stringy and good at producing whips, and some of it's very stock and good at producing chains. And it also means some of the labor is more skilled at making whips and some of the leather is more skilled at making chains. Okay, in this case we have a curved production possibility frontier, and you'll notice that the opportunity cost of producing a whip increases as more whips are produced. And we'll look at what the opportunity cost of producing a whip is in a minute. The opportunity cost of producing one chain also increases as more chains are produced. Okay? So when you have input specialization, you're going to get a curved production possibility frontier. It's going to be curved about outward from the origin, which means the opportunity cost of producing one good increases as more of that good is produced. Again, anything in the interior of the production possibility frontier is dominated. That is, we can do better than that, so we wouldn't produce there. Anything to the right of the production possibility frontier is somewhere we can't produce yet given the resources and given the technology. Okay, let's look at how to find the opportunity cost of a whip. Okay, if we go from point A to B in the graph, you're going to get 10 whips and you're going to give up 5 chains. That means you're going to move resources to produce whips, and those resources produce 10 whips, and they would have produced 5 chains for you. So you get 0.5 chains as the opportunity cost of the first 10 whips. The next 10 whips, you give up 15 chains and you get 10 whips. The next 10, you give up 20 chains and you get 10 whips. And the last one, you give up 30 and you get 10. Notice the opportunity cost of whips is increasing as more whips are produced. If we did the same thing for chains, you would find that the opportunity cost of chains also increases as you produce more chains. So when you have input specialization, you have increasing opportunity cost. That's called the law of increasing marginal opportunity cost. That says that as you produce more of one good and less of the other, the opportunity cost of the good you're producing more of increases. Okay. Now let's look at how a curved production possibility frontier changes when you change things ceteris paribus. If we double the amount of all input ceteris paribus, keeping the specialization constant, the production possibility shifts out like a parallel shift. That means the percentage change in whips equals the percentage change in chains. Okay. If you double only the amount of inputs good at whips, you get a few more chains produced, but you get a lot more whips produced. So the production possibility frontier goes to the right but becomes flatter. It rotates. Now the opportunity cost of producing one whip in general falls, and the opportunity cost of producing one chain increases.